Hi, PerspectaWeather.com meteorologist Paul Dorian here. We are now past the midpoint of the month of April, rapidly closing in on the official start, June 1st, of the Atlantic Basin tropical season. I thought we'd go through some of the factors that I believe will play a major role in the upcoming tropical season. One of the first things I like to take a look at whenever dealing with longer range forecasts or longer range outlooks is to look at the sea surface temperature anomaly pattern around the world, specifically in the Pacific and Atlantic Oceans. Try to determine what that pattern will look like later on in the summer and into the fall. Also like to take a look at some analog years that featured similar types of sea surface temperature patterns that, again, I expect to see later on in the summer and the fall. Kind of want to show right up front here the bottom line, the executive summary. I believe it'll be an active tropical season in the Atlantic Basin, more storms than normal, probably on the order of 13 or 14 or so, maybe 7 or 8 hurricanes, 3 or 4 major hurricanes, a little bit above normal for the Atlantic Basin tropical season. The two factors that I'm really focused in on, and we'll talk a lot about over the next several minutes: La Nina, colder than normal waters in the equatorial part of the Pacific Ocean. La Nina conditions should develop over the next few months and really become the main player by the middle or latter part of the summer, and looks like well into the fall season as well. In addition, warmer than normal sea surface temperatures in the Atlantic, the tropical part of the Atlantic, all the way extending from the west coast of Africa through the Gulf of Mexico to the western Atlantic Ocean, will also play a role. Both of those, the La Nina in the equatorial part of the Pacific Ocean and warmer than normal waters in the Atlantic, are favorable for tropical activity, both in terms of development and intensification. The analog years suggest we may have a warm and wet type of summer in the eastern part of the nation, especially the mid-Atlantic region, and we'll kind of talk about that as well over the next couple of minutes. One other point I have listed here up front, I want to mention the warm water in the Gulf of Mexico is very impressive, and even in some patchy spots along the east coast, just off the east coast, the waters in the western Atlantic are quite a bit above normal, and that kind of sets the stage for the southern and eastern U.S. to be quite vulnerable this year to tropical hits. Again, very, very warm waters, and we'll see that in a moment here over the Gulf of Mexico. It kind of certainly raises the concern of some what I like to call homegrown type systems that develop quickly close to the U.S. mainland, over the Gulf of Mexico, the Bahamas region, the western Atlantic, as opposed to those African waves that move all the way across the Atlantic Ocean. Generally, the homegrown type systems are more favored during the second half, the latter stages of the tropical season. So again, I have to keep an eye on this all summer long and into the fall in the southern and eastern U.S. Well, before we take a look ahead at what the main factors will do to our tropical season in the Atlantic Basin, let's look at last summer and fall 2019 tropical season. It was an active year. Numerous storms. Once again, it really followed active years in 2016, 17, and 18. A lot of these storms last summer and fall stayed out over the Atlantic Ocean. You can see the storm tracks from all the named tropical systems in 2019. And again, a lot of these stayed out over the Atlantic. Some were actually rather short-lived and never did impact land. The storm that 2019 will probably long be remembered for was Hurricane Dorian, and that was this particular track right here. Entered the Caribbean Sea and then developed rapidly into Category 5 status on its way to the Bahamas right here. It stalled right in this region. Again, this is Hurricane Dorian we're talking about last year. Stalled out for maybe a 24-hour period over the Bahama Islands. Never did reach Florida, thankfully, and then scooted up to the north, kind of brushed the Outer Banks on its way to the north and east. So again, 2019 was an above normal year. Probably will be most remembered for Hurricane Dorian, which again reached Category 5 status, caused all kinds of havoc over the Bahama Islands, and then brushed the Outer Banks of North Carolina. Now, one other thing I'd like to point out here is notice the southern and eastern U.S. really did not have a major impact last summer and fall. Right in this region right here, one storm up in this area here, another one crossed over the southeastern U.S., but for the most part, the southern and eastern U.S. were not impacted greatly in the 2019 season. Again, as we said up front, a little bit more concerned this year because of the real warm waters nearby. We'll see that in a moment here for some homegrown type systems that could indeed have an impact on the southern and eastern U.S. Well, here's a list of the names that will be used during the upcoming season, beginning with Arthur. And again, officially the hurricane season begins on June 1st, but of course that's an artificial beginning. It can begin anytime it wants to, and hopefully we won't go all the way down to W, but indeed I think we could go through halfway through the alphabet with maybe 13 or 14 named storms during the upcoming Atlantic Basin tropical season. Well, now let's take a look at the current sea surface temperature anomalies, again, a very important part of the tropical outlook. And by the way, all of these words and figures here that we're going through during this video discussion are right there in the posting on the 2020 tropical outlook on the PerspectaWeather.com website, so you certainly can go back and reference these figures later on. Here we are in the middle part of April, and here's what the sea surface temperature pattern looks like right now. This line right here represents the equator, and notice a little patch of blue here right off the west coast of South America. This is perhaps a sign for the beginnings of a La Nina formation out in the equatorial part of the Pacific Ocean. A little bit of a blue showing up right in here, but I do believe that over the next few months we'll see a much more expansive area of colder than normal waters in this region right here, the equatorial part of the Pacific Ocean. We'll see in a moment here numerous computer forecast models suggest that, and we have other reasons to believe that the models are correct in their projection of a La Nina. We'll talk about that as well over the next couple of minutes. So again, right now we do not have a La Nina. The basis of an above normal type of season is with the idea that La Nina will form. Now, when there is a La Nina or colder than normal waters in the equatorial part of the Pacific Ocean, generally there is less wind shear in the tropical Atlantic, right in this region right here, and less wind shear is a positive factor for the formation or intensification of tropical activity in the Atlantic Ocean. On the contrary, if there's an El Nino, warmer than normal waters out over the equatorial part of the Pacific Ocean, generally there are stronger winds over the tropical Atlantic, and that's an inhibiting factor. But all in all, if indeed La Nina does form over the next few months, that will be a favorable factor for tropical storm formation in the Atlantic region. Now, let's focus in on the Atlantic right now, and look at this right here. Over the Gulf of Mexico, much warmer than normal conditions, and again, that raises some concern about homegrown type systems that form over the Gulf of Mexico, and generally that happens in the second half of a tropical season. And therefore, the southern, eastern U.S. are certainly vulnerable this year for some tropical storm hits. Notice in general, the tropical Atlantic above normal, as represented here by the orange and red, generally above normal in this region right here. And like the La Nina in the equatorial part of the Pacific, warmer than normal temperatures in the Atlantic is a positive factor for the formation of or intensification of a tropical storms in that part of the Atlantic Ocean, all the way to the Caribbean Sea above normal, even some patchy areas well above normal just off the east coast. Well, certainly one of the reasons why we believe La Nina will form over the next few months is because the pretty widespread support in numerical models. This is a compilation of all kinds of numerical models, from dynamical to statistical models, and on average they all support the idea of the development of La Nina. What we're looking at here is anything above this line going across right here represents El Nino conditions, and anything below La Nina. The farther up here, the more the positive, the stronger the El Nino, and the more the negative, the stronger the La Nina. And on average, this compilation of numerical models follows this blue line right here, and that brings things down into negative territory or La Nina territory, where the sea surface temperatures will be below normal. What we're looking at are rolling 3-month time periods. So for example, this right here represents June, July, and August. In general, La Nina on average, as depicted by these compilation of numerical models. Then we have July, August, September, October, and September, October, November pretty much covers the tropical season. Again, on average, La Nina conditions. We'll take a look right now at one specific model right here, as shown in the green, right in this region right here. Kind of one of the outliers that has a strong La Nina. Not the strongest. There's a couple other models that are even stronger, but this happens to be the NOAA climate forecast system model. We'll take a look at that particular model right now. And here we go. This is the forecast map by NOAA's climate model called the CFS V2, Climate Forecast System version 2. It's for the June, July, August time period. A couple things that I want to point out in particular. La Nina right here across the equatorial part of the Pacific Ocean. This is the west coast of South America. Clearly, this model supports the idea for La Nina formation. And again, La Nina in the Pacific is a favorable pattern for tropical storm formation in the Atlantic Basin. Notice also throughout the northern half of the Atlantic Ocean, above normal temperatures here, as depicted by the this particular model. This is the west coast of Africa right here. Lots of yellows, oranges, and red, indicating above normal sea surface temperatures, a favorable pattern for tropical storm formation in the Atlantic Ocean. Well, let's go out a little bit farther in time. It generally looks the same here. This happens to be for July, August, September. The same model, the NOAA's CFS V2. La Nina here, generally warmer than normal conditions here in the northern part of the Atlantic Ocean, both favorable for Atlantic Basin tropical activity. Let's go one more month out into the future for these rolling 3-month time periods. And this is August, September, and October, virtually covering the entire tropical season here. Look at this La Nina here as depicted by the CFS. Perhaps it's strongest here by the latter parts of the summer and the going into the fall season. Continuation of La Nina and continuation of warmer than normal temperatures in the Atlantic Ocean, both favorable factors for tropical activity. Well, here's an interesting plot I want to show here. This is kind of a supporting plot here, supporting data for the idea from these numerical models that indeed La Nina will form. What we're looking at are the water temperature anomalies from the surface down to 300 meters in the equatorial part of the Pacific Ocean. In other words, the top 300 meters of the tropical Pacific. And blue represents colder than normal, and oranges and red, yellow above normal. Right here, this is the international date line right here, cutting across this region right here. And just take a look at what this is suggesting right here. First of all, this is actually the colder than normal waters that we pointed out earlier already at the surface. And again, this is the surface level right here, and then we go down all the way down to, this is the 300 meters below the surface. So this entire area is kind of a cross section, the top 300 meters in the tropical Pacific. This is the colder than normal water that has already reached the surface just off the west coast of South America, kind of the beginnings of the La Nina. And notice what's going on here. We have a lot of colder than normal water right below the surface out over the central part of the Pacific Ocean. Very likely that as soon as the wind conditions change at the surface level, the trade winds will get some upwelling. And upwelling is when the colder water from underneath rises up to the surface. So this is kind of a supporting idea here. The fact that we see all that colder than normal water just below the surface in the tropical Pacific gives certainly raises some strong feelings that the numerical models are onto something here in terms of the prediction of La Nina formation. Again, colder than normal waters already at the surface just off the west coast of South America. A little bit of upwelling will bring this up to the surface over the next couple of months. Well, in addition to looking at sea surface temperature anomalies, I like to focus in on analog years going back 50 or 60 years to see what years featured the same kind of sea surface temperature pattern that I expect to see later this summer, later in the fall, namely La Nina in the central and eastern Pacific and warmer than normal water Atlantic temperatures here. And we have 5 years listed right here that are pretty analogous to what I expect to see in terms of sea surface temperatures. In fact, this is the overall pattern. When you average these 5 years together, this is the sea surface temperature pattern that is the result. And this is the forecast map for later this summer. And again, the key factor here is La Nina in the tropical Pacific Ocean and generally warmer than normal waters in the Atlantic. This is the average of these particular 5 analog years, very close to the forecast of the sea surface temperature pattern with La Nina here in the tropical Pacific and a warmer than normal northern Atlantic. So we have some confidence in these particular years that they are quite analogous to what I expect to see later on in the summer and the fall. This particular data, by the way, comes from tropicaltidbits.com. When you take the average of the number of tropical storms in these particular years, a number of hurricanes, they match up pretty well with our forecast, maybe 13 or 14 named tropical storms, maybe 7 or 8 hurricanes, and 3 or 4 major hurricanes. Again, supported by taking a look back at these particular analog years. Well, not only do I like to take a look at those analog years in terms of the tropical activity that took place during those particular summer and fall seasons, but what about the overall temperature anomalies and precipitation anomalies? And indeed, if you look at those analog years on average, using all 5 of those years, generally, this is the temperature anomaly composite map here, generally warmer than normal conditions in the eastern half of the nation, including right here in the mid-Atlantic region. So this is why I'm leaning towards a warm, and we'll see in a moment here, a wet type of summer in the mid-Atlantic region with maybe temperatures averaging a few degrees above normal in the summer season, and in terms of precipitation, maybe a few inches above normal in terms of overall precipitation. So again, the analog years suggest warmer than normal conditions in the eastern half of the nation, maybe a mixed bag of nearly normal overall out across the western U.S. Now, in terms of precipitation anomalies from these analog years, blue here represents above normal, wetter than normal conditions, and generally eastern half of the nation near normal to above normal. Again, I think we're in an overall active weather pattern. It looks like that'll continue. It's kind of been the way for a year to 2 in much of the eastern half of the nation. So I think in general for the mid-Atlantic region, a little bit warmer than normal, wetter than normal, and throughout much of the eastern half of the nation, the same sort of thing on the warm and wet side. The western half, nearly normal in terms of temperature, and it looks like generally nearly normal in terms of precipitation as well. Well, one final map I'd like to show here in terms of what to expect this summer in terms of temperature and precipitation anomalies. The U.S. Drought Monitor map here, where if there's no color here, it shows normal conditions. And while I expect the Mid-Atlantic and much of the eastern U.S. to be warmer than normal, I don't necessarily think it'll be an excessively hot type of summer here. Excessively hot type of summer is definitely favored when there are drought conditions. We do not have any drought conditions right now throughout virtually all of the eastern half of the nation, the only exception being along the Gulf coastal region. We are in an active weather pattern. I believe it'll stay an active weather pattern. We still have cold air outbreaks to deal with in the central and eastern U.S. going right into the early part of the month of May. With cold air outbreaks, that to me supports the idea of continuation of active weather, meaning more rain coming, and I don't see a drought forming anywhere in the Mid-Atlantic region in the latter part of the spring or going into the summer. So in drought conditions, you really can have excessive heat because the sun's energy, when the top layers of the soil are rather moist, some of the sun's energy is actually used up in the evaporation of that moisture before it heats the ground, which in turn heats the lower atmosphere. So the hottest summers are when there are drought conditions in the Mid-Atlantic region. I just don't expect to see that right now. We're not seeing it now, and I don't think we'll see it over the next several months. Well, let's kind of wrap up by going back to where we began this particular video discussion with the executive summary here. Again, based on La Nina in the tropical part of the Pacific Ocean and warmer than normal waters in the Atlantic Basin, the tropical Atlantic, I expect to see above normal tropical activity, perhaps 13, 14 named storms, maybe 7 or 8 hurricanes, 3 or 4 major hurricanes, and the fact that the water in the Gulf of Mexico, for example, is way above normal raises some concern on my part for the southern and eastern U.S. Parts of the western Atlantic have some areas of very warm water as well, and that really is a concern during maybe the second stage of the tropical season, because the first half generally is dominated by these African waves that come off the west coast of Africa, ride along the trade winds excuse me, from the east to the west into the Caribbean, into the Gulf of Mexico or the western Atlantic, whereas the second half tropical season you often get these homegrown type systems that form suddenly over the Gulf of Mexico or the Bahamas region, and that's kind of a concern here for the southern and eastern U.S. with those very warm waters. And then by looking at some analog years and what kind of conditions took place in those analog years, it looks like we're probably headed for a warmer than normal or wetter than normal summer in the Mid-Atlantic region, and really throughout much of the eastern half of the nation, whereas the western U.S. generally near normal in terms of temperatures and precipitation. So we will certainly continue to monitor all of this over the next several weeks here at PerspectaWeather.com. For PerspectaWeather.com, I'm meteorologist Paul Dorian.